Up the presentation of.
Okay, all right. Welcome everyone back to our session 4 of Cloud Computing series. And I think today it's going to be an extension of what we saw in the previous session, and it's all going to be about Kubernetes. And it's my pleasure, it's like always my pleasure to welcome LG. She's a bundle of knowledge, I should say, and I'm happy that she's so humble and happy to be our speaker again for the second time. So Lakshmi Gayatri is a senior manager working with R&D VMware. So she has a deep knowledge of Kubernetes and cloud native apps. She's an open source enthusiast and leads a team of contributors to develop vSphere. And she also interacts with customers and an active speaker for VMUG Bangalore and Mumbai. She's a track chair for GHCI, the Grasshopper Conference, a leader in Women Who Code Bangalore chapter, and she's an eminent judge and mentor for Smart India Hackathon run by Government of India. Very happy to welcome you, LG.
Thank you so much, Pavitra, for your kind introduction.
Okay, and with LG, we have good evening, everybody. So that was LG for you. And also we have Rida, who will be taking this session. So Rida is a member of technical staff at VMware, and she has around 1.5 plus years of IT experience in building software apps and integration solutions. And she has domain knowledge in Docker, Kubernetes, and is working on OSS for developing operators to make vSphere the best platform. She's Associate VP Education at VTalk Toastmasters Club. Rida has done several webinars and presentations on machine learning and cloud computing, and she's also a leader in Women Who Code Bangalore chapter. So welcome, Rida. Welcome, LG. Over to you. Without further ado, let's dive right in.
Thank you so much, Shivanjali.
Thanks.
Okay, here we get started then.
Yeah, sure. Shall I start?
Yeah, Rida.
Okay. Good evening, everyone. And thanks for joining us on a Friday evening. I hope you all have some tea or coffee next to you to embrace yourself and enjoy the session with us today. So in this series of What's in the Cloud, this is our second session. I hope some of you were able to attend the first one, which was based on containers. So today, before starting the session, which was based on Kubernetes, let us see what we have in previous session. So we discussed basically about what is a container, what is Docker, and what is its architecture. How do we run different images using Docker and create the containers, layered file system, and the internals of container. LG, next slide, please. So before we start today's session, let's have a quick poll so that we know how many of you were able to attend and how many of you were not, so that we pace the session accordingly. Can you please paste the answers in Zoom chat as yes or no? Okay. So I see a mixed reaction, most of them being no. So that's okay. We'll cover some part of the previous session so that we are in sync. So let's discuss about what is a container and the Docker architecture. Then we'll move to Kubernetes. First of all, what comes to your mind when we think of a container? So in layman terms, we have always heard of container as a box which has a fixed size and has some contents inside it. So similarly, here the contents can be related on the code to which needs to be executed along with the dependencies. Something like the executables along with the libraries that the code needs in order to get executed. Given this, there is no dependency on the platform. So the containers become an independent identity which can execute on itself on any platform and can lift and shift between the different versions of platform. With containers, each service has its own dependencies isolated within the container. And with this, we should be able to avoid work on my machine scenario. So container is basically a standalone executable package of software which includes everything that is needed to run an application. Next slide, please. Now let us discuss about the architecture of Docker and how it works internally. So as Docker is an open source software, so it can be directly downloaded from docker.io and can be installed on the system. Docker follows a client server model, which includes three components in the architecture, which is including Docker client, Docker host, and the registry. So here we can see the first block. We have Docker client, which can be referred to the system on which we are installing Docker and running the command. So we can refer to as the local system on which on any Mac or Windows we are running the normal commands or the applications. On the client side, the Docker uses the APIs to communicate with the Docker host and sends the instructions. Inside the Docker host, we have the Docker daemon, which looks at the images and provide an environment for the container to run. And each of these containers are created from the Docker image. This image can be defined as a template of instructions and metadata, which is required for the container to run. The Docker image do not have any process running inside. It is just a template which contains all the instructions and all the binaries which is used to spawn a container and then run the container. Once the container is up and running, the process runs inside the container. These images, which is used to spawn the container, LG previous slide. Yeah, thank you. These images are managed and stored in repositories. It can either be public or private. Docker has its own repository, which is again Docker Hub. We can push our images to the public repository, which Docker provides. Or we can use any private repositories like the JFrog to have any other sensitive data stored in it. Docker daemon fetches the images from these registries. For example, we have command like docker build to build the image locally on the system, docker pull, using which we can push the images to the registry, and we have docker run, using which the images which we have stored locally on the system, we can start the we can run the images and start the container to run our process. Next slide, please. Okay. So far we have discussed about containers, Docker, and the architecture of Docker. Now let's see how do we manage these things in production. Say all of these blocks are containers and our company VMware has all of these things running in production. So how do we manage them? The ship which we see here, this is what we need for managing these containers. Next slide, please. So we all have heard of Kubernetes, which is used for managing the containers. But as we all know, before moving to anything, we all want to know the why aspect of it. Why should we use it? And why do we need it? So why do we need to, first of all, manage the containers? In our local systems, if we see, we have a few number of containers which are being deployed, and hence we can manage them easily. But let's say at the production level, we have thousands of containers deployed, and the management of these containers require a great overhead. Also, in our local system, let's say I was running a container and it failed. So it is not a tedious job for me to just restart the container and restart the process. But on the other hand, if we have millions of containers running in production, so failure and recovery of all of these containers cannot be tracked and looked upon and at the same time. Also, the networking and the upgrade of these containers is cumbersome. So we do need some recovery mechanism and some management mechanism. This leads to the introduction of Kubernetes. Kubernetes is an extensible open source platform which can be used for the orchestration of these containers, for managing and deploying these containers. Kubernetes also offers load balancing. So if the traffic is high, it is able to balance the load on its own and distribute the traffic to make the deployment stable. Also, it provides failure recovery. So let's say if the containers fail, Kubernetes will restart, respawn the containers, and also it kills the container which do not come in running state on many retries or do not respond. So we do have many other advantages of Kubernetes, which we will discuss later once we go through the core concepts of Kubernetes. Next slide, please. Now let us discuss about the top orchestrating tools which we have available in the market. So first of all, we all are aware of Kubernetes, which is undoubtedly the market leader in orchestration, and about 68 to 70% of the workload is using it as a base. From VMware also, we have many contributors to Kubernetes. So since Kubernetes is open source, so any one of us can contribute to it and work on it. The second one is being Docker Swarm. Despite Docker being the great container technology which it brings in with it, but orchestration is also equally important. So then Docker introduced Docker Swarm. But by then Kubernetes have evolved a lot, and the customers who have stuck to Kubernetes are not ready to move to Docker Swarm or some other orchestrating tool. We also have Apache Mesos, which has container orchestration for data centers, and we have Nomad, which is also gaining momentum because of its simplicity, and also it's a startup. Next slide, please. Yeah, so let's look at some of the stats of Kubernetes. Here we can see 5.6 million developers use Kubernetes with an increase of 61% in just 1 year. So since many people are moving towards this technology, and we can see a huge number in last 1 year. So we can see the momentum growing for this technology, which it is bringing in. And also on CNCF, which is Cloud Native Compute Foundation, which manages all the open source projects. Kubernetes can also be found there. Hence, it is not at all tied with the original developer and is completely open source. Next slide, please. Yeah, so I have this game with me. Could you please mention in the chat window what game is it, if anyone recalls? This has gained a lot of momentum during the pandemic, right? Okay, so I'm glad that one of our attendees know that. This is Fortnite from the company Epic Games. So after the pandemic in March 2020, the game saw a scale of 125 millions concurrent users. So the number is really surprising, but it gained popularity so that everyone was not getting to move outside and was just surfing on this game. Earlier, the scale used to be 5 million worldwide. So from the time of pandemic started, people started spending more time on the OTTs and games like this, where they feel like they're actually in that avatar and have their team. So because of these many users, the data this game generated in just 2 months was 2 petabytes. Yeah, you heard it correctly. It's petabytes. So if we start putting them into DVDs of 4 to 5 GB, that would be like 223,000 of DVDs that would fill in the room itself. So, but the beauty of the game is that they never had a downtime. They never had to re-architect it, even with this many scale. Since it is hosted on Kubernetes, and since it is managed by Kubernetes and is hosted on AWS. So AWS keeps this in mind that this game do not have any downtime. Also, if anything gains popularity, we have many hackers that try to stop it, but even any of the hackers cannot stop this game. So it did not have any downtime. This is all based on containers, Kubernetes, and clouds, and we can see the scalability aspect of it, which this website has. Next slide, please. Yeah. Now that we have already seen the architecture of Docker, let's see the architecture of Kubernetes. So the end user, let's say me, I am interacting with the API server. So if I have to provide any instructions to the Kubernetes cluster, I have to talk to the API server. For sending the instructions to the API server, we do not have to know the underlying working of it. We do have a command line interface, which is known as kubectl, which is similar to the Docker commands which we had in Docker. So the user can talk to the API server and not of, as I mentioned, not to any other entities directly. So from the talking about the parts of the master, from the symbol itself, we can see what etcd is. So etcd is basically a database, and all the data which is present in the master VM or the control plane that gets stored in the etcd. Apart from that, we do have a scheduler and a controller manager. So as container is the smallest entity that can be deployed in case of Docker, here we have pod as the smallest entity that can be deployed on Kubernetes. I have introduced a new word, but we'll talk about it in detail later. Scheduler, let's say, is a process which assigns the pods to the nodes, and controller manager can be referred to similar to a teacher who keeps an eye to the students. And then we have nodes or the workers. Inside the node, we have kubelet, which is similar to the client agent. If we consider the client server architecture, so the kubelet is the agent running inside the node and which is talking to the API server. That, hey, I'm the node, and you can provide the instructions and spawn the pods on me. So the kubelet is what that talks to the API server, and then we have Docker. Kubelet can only talk to the API server, and the API server can only talk to etcd. API server can be referred as the heart of the master VM or the control plane. In this example, we can see we only have single master and 2 nodes, but in production, we have multiple masters, say 3 masters supporting the workers for high availability and no downtime. And with those masters, we have a load balancer to balance the load with those masters. Next slide, please. Yeah. As I said about the word pod, so as container can be deployed as the least unit in Docker, similarly, pod can be deployed as the least unit in Kubernetes. And pod has come from the word tpod itself. So here in the 2 pictures, we can see one of them who have only 1 P and the other having multiple P. So if we can try to connect this with the pod in Kubernetes, a pod can have either a single container or multiple containers. The pod has its own address and the container do not have their own address. So if the pods want to talk to other pods, if the containers want to talk to the other pods, they have to go through the pods. Next slide, please. Yeah, now let's see what a scheduler is. So here in the picture, we can see the scheduler is similar to a crane. So what crane does is it lifts some material from, say, point A to the destination place point B and lift and shift of the object. Similarly, when the pods are coming, the scheduler makes sure the incoming pods are scheduled onto the nodes. So in Kubernetes, all the work is done by the nodes, and the scheduler just schedules the pod to the node. Yeah, next slide, please. Okay, now let's move to the controller manager. So the controller manager can be referred as to the class monitor who has been told by the teacher to keep an eye on the students and just note down the name of the students who do not behave the way they are told by the teacher and give an intimation to the teacher about them. Similarly, the controller manager is always watching the system. Since we have declarative approach in Kubernetes where we can say what I want to do and need not worry about how it is being done, that is being taken care by Kubernetes. So the controller manager keeps a check on the system if it is in the ideal state as it is defined by the user, and have a control loop on checking if it is in the ideal state. Say the teacher told the monitor to keep a check on all of the students that they are in the sitting position. So the monitor makes sure that the position of the students are seated and makes the person sit again if anyone stands from them. So in a nutshell, controller manager keeps a check on the desired and the actual state and make sure that both of them are the same. Next slide, please. Yeah. So the next one in the queue we have is the control plane. The control plane is the boss. So in the architecture, LG, can we move to the architecture once? Yeah, so here in the architecture, we can see the master is responsible for performing all of the operations. So the master, which we refer to as the control plane, which is the boss, which takes the decision according to the inputs coming from the scheduler and the controller manager and tells them what to do. So all the components like HCD, API server, the scheduler and the controller manager sits inside the control plane. Like we referred previously, API server as the heart of the system. Similarly, we can refer the control plane as the brain of the system. Yeah, we can move to the previous slides. Yeah, next slide, please. Now let's talk about the nodes. Here we have put minions. So can anyone guess why? It is from the movie Despicable Me. So there might be some reason why we have the minions here put for the nodes. Can someone draw any analogy? You can type in the answers in the Zoom chat. Come on. Okay. Yeah, that's true. To get scheduled, right? They do all the work. Exactly. That's what I was searching for. Yeah. So you're absolutely right. In the movie, all of the work was done by the minions. Similarly, the nodes are the ones who does all of the operations by taking the pods on them and having the job done. So all of the job is done by the nodes, and we do not have any limit on the number of nodes. So we can have any number of the worker nodes, and all the pods are being placed on these nodes. Next slide, please. Coming to the namespaces. Namespaces have the declarative approach of reserving the resources. So here namespaces, let's say there are 4 friends who live in these 4 houses. So all of the family of these friends have their own resources in each of these houses. So let's say there are those 4 friends A, B, C, and D. So person A has some resources which is being provided to it by their family and is confined in their space. Similarly for the other ones. And if they are living in a society, so let's say the public park or some well, they do have access to this. So all the common resources are being accessed by all these 4 namespaces or the 4 houses. One more thing, if we consider, let's say there are 4 classrooms and there are 2 students, say Rida, Zuber, in standard 4th and standard 5th. So how do you differentiate both of those Ridas? You can say one of them is from standard 4 and the other one is from standard 5th. And the common resources, let's say the teacher which teaches in both standard 4th and standard 5th. So she is the common resource here. She is being I mean, not used by both of the classes, but she's being accessed by both of the classes. She teaches in both of them. Similarly, here namespaces, we can connect to the analogy and we can say all of the pods or the resources which are deployed in that namespace are confined in that space, and they do share all the common resources which is provided by the cluster. Next slide, please. Yeah. So the next one is being the replica set. This is similar to scalable containers. So like we have seen, if the load is more, the containers can scale from 10 to 15 to 100 depending upon the needs. Similarly, in the replica set, we can provide a number or a limit till when it can scale up to. So taking the example of this meeting itself, let's say in this meeting, we had a limit of 50 participants. So if any other participant, that is the 51st participant, want to join in the meeting is locked and it's not allowed to join. Similarly, here in the replica sets, we have a count mentioned, and according to the count, the number of pods are allowed in it. To explain more about the replica sets, LG will be taking over the session. Over to you, LG.
Yeah, thanks, Rida. I was just answering Satyajit's question, so probably I'll finish talking here, and then if you want, you can also respond. Just wanted to tell him that namespace is just a logical parameter for all the resources which we can just put inside. So for the replica set, right, as Rida said in the previous example, so replica set is what, like you have exact same copies of an inventory object. And then you must be thinking, I have only like finite number of nodes in my example. How do these replicas get placed? So these replicas, which are like in this example, we'll say pods. So these pods have to be placed onto these nodes. For example, here we have 3 nodes, node 1, node 2, and node 3. And we are telling Kubernetes that I want a replica set and the count of it is 6. Which means that for the given type of a pod, I need 6 such copies of it, and that is going to spread across. So this is decided by the control plane on how many has to get into like P1 on node 1, how many has to go to node 2, how many has to go to node 3. At times, you can also happen that there are no pods scheduled on some of the nodes. But usually, in case there is some issue with the resourcing or the capacity, then automatically Kubernetes is going to place the pods onto the respective nodes. And similarly, like how you have these replica sets, right? We also have another important deployment type that is called the Daemon Set. So Daemon Set, what it does, it will have exactly only one copy of the pod onto each node. Just one, it cannot go beyond. So you don't have to give Daemon Set any number. If you see the definition, right, we didn't give any counter. By default, it checks how many nodes are attached to the master. And on each node, it's going to write one pod. The advantage of this Daemon Set is, for example, you have some jobs like a sidecar job or something, and you want it to get executed within the node on a fixed pod. Usually we use it for logging. You are aware, right? Pods are ephemeral, which means that pods are not, containers are not like virtual machines. I mean, to just go back a few steps, virtual machines persist data, and you can have your virtual machine like in a power down state for very long. And then when you do operations, they retain all the information. And then even if you reboot, it will start from the last known good configuration. But in pods, what happened is, usually pods don't live long. They have a tendency to go down, and then again they'll be brought back new. There is nothing which is like an information that they'll have to recall and retain. For debugging purposes and for other monitoring and metrics purposes, we usually push something like a monitoring or a logging pod into these nodes so that we keep collecting the information. What happens even if the pod goes down, we still have the log to look at like what really happened. Troubleshooting is very important, and Daemon Sets help us a lot while troubleshooting some of the problems with Kubernetes applications. And next is declarative versus imperative. So you may have heard that Kubernetes follows a declarative model. So declarative model I mean, if you have worked with Kubernetes, you can give us an example, or you can type it in Zoom chat, like what exactly you think of for declarative. Just take a minute to see if someone is going to attempt. Yeah, for stateful set, what we do, Satyajit, I'm just switching gears for this question. Usually we have a persistent volume attached. So for all the data which needs to persist in that particular set, it will be returned to the persistent volume. So even in case there is something wrong with the pods, the volume still holds the data. And when the new pod comes into the declaration with the PVC bindings, it will make sure that it gets attached to the disk where the data is there. So just think of it like your SD card or your removable hard disk where you store all your backup. In case you want to copy something from your laptop, you just connect it and then copy. Even if the laptop and the SD card is disconnected, does not mean the data gets erased on the SD card. Data will still be there. When you connect, you'll be able to access. Very similar to that for stateful. Yeah, correct. Satyajit is right. Yeah, declarative means with a set of instructions. So this set of instructions, what we do is, one example which we use it on a daily life is, say you are booking Uber. From my home, if I'm booking to Bangalore office, Kalyani Vista office, in Uber you just give a location and then you book a ride. But you don't, when the cab arrives, you don't tell the driver where to take right, where to take left, where to avoid signal, where to avoid a U-turn. So similarly, Kubernetes also, the moment you say, this is my desired state, that I want to go from home to office, and getting to office is the desired state, it will make sure it take incremental steps for you to be there, just like a Uber example. And then the imperative is on the other side. So imperative, in the same example, I'll tell you, like in case suddenly the Google Maps goes down, the Uber app is not updating the Google Maps, or the maps shows offline. In that case, for the person who is driving, they'll be like stuck. They don't know where to go. So that is when if you are there and then you can give directions like, hey, take left here, take right, or go this way. That becomes imperative. So Kubernetes as such, it is always follows the declarative approach, where you only define what is your desired state, and the automation and orchestration takes care of getting you there. Imperative will be very tedious because every step you'll have to have if conditions and then make sure that you are going in the right direction. And the other one is YAML file. This is yet another markup language, is the simplest way, and there are a couple of more full forms as well for this. And this is how we write a YAML file for Kubernetes. Previously in the last session, I mean, if you have not attended also, that's fine. We have recorded that session. It will be there in the cloud series, What's on the Cloud. You can refer to the sessions which have happened in the month of April. You can find it there. Very similar to like how we write a Docker file, right? In Docker file, first line would be from which layer of operating system you are building the Docker image. Like you start with that and then you say run Python or do some pip install, like that. How do you layer the things and create a Docker file? Similarly, in Kubernetes, we use YAML. This is very case sensitive and also space sensitive also. Very much like Python. If in Python, even if you have an extra space, compilation fails, right? So YAML is also like that. It starts with API version, and you can choose any version like V1, V2, V3, and then kind is what the objects which we have shown earlier. We showed you about the pods. We showed the Replica Set, Daemon Set, Namespaces. So all these things come under kind. And this is a metadata. Metadata is usually the data with which you talk to it, in the sense like, say I want to refer something, could be a label, or it can be something like a name of the entity. So we have name as NGINX for this container, and a spec is something which defines the properties of the object you want to create. In the property, we are saying containers, and then we are giving a name as NGINX. The image is NGINX with the version. This is the version tag. And the ports. NGINX is like a HTTP server, right? It usually runs on port 80. So that's why container port is 80 for this. Like this, you can have a bunch of containers. Whenever you see a colon like this and this, it's a list. That hyphen indicates list. And as you recall from the example which Rita gave, in a pod, you can have either one container, or you can have a pod which has like about 10 containers. 10 containers is the limit. So these 10 containers need not be the same image. They can come from different, like you can have nginx, one can be Redis, one can be Postgres. Like that, you can have a combination of it coming together into one pod. It will still be one pod, but different containers. So you can just keep defining the name tags. It's like a list. And you have a lot of examples on k8s.io. So k8s.io is kubernetes.io. Between K and S, there are 8 English alphabet. So that is the reason it's called K8s, Kubernetes. And you can, for understanding some of the concepts and taking some ready to use YAML files, right, you can refer to k8s.io. So you have very good documentation, you have blogs, and also there's a systematic explanation for each of the entities. If you want to get more insights into it, you should try this Kubernetes.io. And the same web portal also has an interactive shell, which is supported by a cloud instance, where you will be able to try these commands, whatever you're learning into that. It's like an interactive learning. So you can read something and you can try it on the interactive shell. And earlier to the session at the beginning, Rida mentioned, right, for connecting to Docker API, you use the Docker as the command. Similarly, for Kubernetes, we use something called kubectl. So kubectl or kubectl is what we call. And there are a lot of commands. There is create, there is get, there is describe, there is delete, all the CRUD operations which you can imagine, exec, similar to Docker. You have all these commands, and then the cheat sheet for each commands also you'll find it on Kubernetes.io. Here, some of the basic things is what we have mentioned. The mostly used resources are the pods, namespaces, nodes, deployments, services, and replica sets. Services, we have different types of services like cluster IP, load balancer, node port, headless service. These are different types of services which Kubernetes offers, because it is like load balancing is very important, right? When you go for enterprise services, load balancer is like, think of it like this. You have one IP address or one FQDN, which is looking at the external world, and it is backed by say 100 systems at the back. You don't need to know the IP address of each of the 100 systems which are supporting at the back. All you need to know is the load balancer IP. The advantage of this is, in case the load balancer, in case in this 100, say 10 nodes have gone down, only 90 are there. Even then, there is no change to the end user who is accessing the load balancer IP, because still it is supported by the 90. And the moment the sync happens, K8s realizes that 10 nodes were down. It will destroy them, bring up new nodes, and then again make the quorum of 100 nodes. So that's when services are very important. Once you start writing some production workloads, right, there you will learn more about services. And next is create. So just like how you do for Docker, similarly for kubectl also, it is kubectl create, and then we'll have to give the location of the YAML file. So YAML file is what we have seen, where it starts with API version, kind, spec, metadata, all these things, metadata and then spec. So here you pass such YAML file, the pod YAML file, and then you will be able to create resources. And where will these resources get created? Any idea? When we are saying kubectl create some pod, right, where are these pods getting created? Yeah, correct. These pods get created on the nodes. The minions example, if you recall, the minions did the job for Gru. So it's very similar to that. All the work is done by nodes. So nodes support these pods. Yeah, there is one question like how to link a Kubernetes with AWS. On AWS, we already have Amazon. We have an AWS Kubernetes service engine. So for your existing org, yeah, if you already have access, it's a service which you can attach for Kubernetes, and then get all the pods, all the Kubernetes constructs into your environment, and it will be like a simple UI to access and then make changes. And once you have such environment, you can directly connect from your corporate gateway to that, connect to the Kube API master, and then be able to deploy your applications on top of it. Yeah, I'll just get to this a little later. Yeah, so these are I'm summarizing the ones which Rida had mentioned. So wherein Kubernetes is self-healing. When we say self-healing, it can autocorrect. It can check that the current state of the system is not matching the actual state. And then it will make some simple corrections so that we get to the actual state. That means it can destroy some inventory objects, create new inventory objects, and then place some pods into some other nodes, drain nodes, taint them for pod allocation. All these things it can take care. And the second one is it keeps checking for the ideal state as expressed in the deployment. So that is the reconciliation it keeps doing. Actual state, whatever is defined, it should be the same as the expected state. Both have to match. If it's not matched, then there is an set of actions which are taken, the Uber example which we took. And then to the actual state of pods and real world operations. So it'll make sure that it plays some cards and then get things done. Yeah, and the most important thing for you for takeaway of this is take a screenshot of this, and for you to learn from the basics of 101, right, on Kubernetes, like why it started, you figured out. Not just because many developers are doing it, we will have to do it, but there is an added advantage of getting into Kubernetes. Most of the legacy applications are moving into cloud native. So that's when, even as developers or folks who are interested in coding or even non-coding, there is a big chunk of market to be captured for Kubernetes. And we are constantly on lookout for folks who are good at Kubernetes, who understand concept. And for Kubernetes, we also have a software language called Golang. Just like you have Java, Python, and Angular or Scala, these kind of languages, whatever you have, very similar to that. For Kubernetes, we have Golang. So Golang is the language in which Kubernetes has been built. If you see the source code of Kubernetes, right, this is open source, so you can go check the source code of it. It's all written in Golang. And when you are working on Kubernetes applications, deployments very closely, so as a user, you can use Python, Java, anything. Mostly Python is used, but then as a developer of Kubernetes, like if you want to contribute to Kubernetes, then having Golang is desired. So that's how, when we also started working on Kubernetes, we also learned Golang before, so that we can understand what is written in the open source, the GitHub, and then understand it and then be able to use it downstream. Yeah, Docker is the one which you see here is for the previous session where we have dealt with. That you can pull images and other things, see your own repository, have your own private repository as well. And CNCF, Cloud Native Compute Foundation, it has all the open source projects. One of them is Kubernetes, Helm, all these are open source projects. So you can become a contributor also. See, one thing what I would say is we also have an open source series talk this month on June 24. Becoming an open source contributor, you can do it by doing your existing job or even while studying. So most often we are seeing that the college students from the third year onwards, they are engaging into the open source community. It can be as simple as just going through some project, downloading the Git repo, even filing a couple of bugs will still make you an open source contributor because you're doing something for open source. And your profile will look very rich because you have done open source, you will be like a cut above the rest even when you go for interviews or some placements. And the other one, yeah, this is the open source repository for Kubernetes. And Katacoda is what Kubernetes IO uses for interactive shell for training purposes. And you have open source, Docker is also open source, you can find the source code there. And in CNCF landscape, you will see the bunch of CNCF projects which have been done. All these are being done with like 800 thousands of developers. and you know, about 180 countries are participating. So those many countries have developers. India also is having its foot forward in the open source. Earlier, in the last decade, when we saw it, the number of open source contributors from India has been very less. But then after, I mean, since the last 5-6 years, the numbers have increased a lot. So all that is because of the awareness in this topic. I'll get to the quiz now. Okay, we have a small quiz. You can type the answer here. In which type of Kubernetes resources we can provide the number of copies required? And I want answers from everyone. Just because somebody answered does not mean that you don't have to type. We have many participants, so everybody should type the answer at least. Then if you type it, if you write it, you will remember. Yeah, that is correct. It is a replica set. It will come very handy when you're dealing with production deployments. And we have one more question. What is the difference between containers and pod? This is not a one-word answer, but a one-line answer you can write. And thanks everyone for answering the previous question. Pods and encapsulate containers. Okay, correct. Yeah. Okay, somebody noted the scale also correctly. Any containers, correct. Yeah. Yeah, all are right answers. So I just want to recall what Rida said. So pod is the smallest unit in Kubernetes world. I mean, that's the smallest one, very thin, just like you have containers in Docker. Yeah, container is the smallest unit in Docker, and pod is for Kubernetes. Okay, with that, let me just go back and then show you a demo which I wasn't sure if we would be able to finish it on time. So let's go back to this demo. So what we will see in this demo is how the YAML file looks like. The one which we saw in the PPT is a very small, simple pod it is, and then this is a little more advanced. There, the kind was pod. Here, the kind is deployment, and it's very similar. Have an API version, kind, metadata, and then have the spec. So the spec will have a list of things. So here again, same example, nginx we are taking, but this time we are taking version 1.8 and same container port is 80. So this is how the YAML looks. And in order to create this pod, what we need to do, in order to create this deployment, what we need to run, what command, what does it start with? Yeah, correct. It starts with kubectl, create -f, and then the location of this YAML file, wherever it is on your system. Right. Now, actually, in school, you would have done this, right? When you write down the answer so that you don't forget. So that's why I'm asking you to write. Yeah, so kubectl, create -f, YAML location, and then you will see a message like this if successfully created. In case it is not created successfully, then you will see like a few lines of error. Usually the lines of error are very self-explanatory. It could be some permissions issues, or it can mean that the YAML itself has some syntax errors. So the error message will be very clear. Read the error message, and then you'll be able to correct the deployment YAML, like in case something goes wrong. And once you create it, usually our tendency, the moment we create, we want to see what we did. So we'll do a get here. And then this nginx deployment is what just got created 6 seconds ago. And then when we get, we want to see more details about it. That's when we use the describe command. So we have used the nginx, which version 1.8. Okay. And then the application name is nginx. Yeah, this is a replica set. So let's go ahead and then change something. Yeah, so the second one is nginx pod. Don't get confused with the other two. So there is like one pod which is running. No, we'll say pod, and then the name of the pod we'll have to copy to describe it. So we have the version 1.8. Now we are modifying the previous YAML file. See, first time when we do something, see this replicas was earlier 1, right? Here if you change, then the next time when you apply, the number of replicas will become 2. So for the same deployment, instead of 1 container, you'll have 2 containers. I don't know if you saw what it was. We changed the version of NGINX. Second time when we do it, right, instead of saying create, we say apply. Same YAML file we are doing. Yeah, and then this got configured. Yeah, so now this is the interesting part. So what you see is, we changed the version from 1.8 to 1.7.9. The previous one which got created with 1.8, that is this 96 seconds one, it went into terminating state. So Kubernetes, by the time you hit enter and then type this get pods command, it saw that you are actually asking for 1.7.9 NGINX, but what we have is 1.8. So it is terminating the pod which is 1.8. And at the same time, when it is doing, it also started a pod which is with 1.7.9. You see the timing, then you'll understand. So this 99 seconds one was what we did before. And this, the one which is 7 seconds, is a new pod which got created. And we haven't done anything. We just executed one command. Now if you say get pod, this pod has to terminate. Yeah, now the pod is terminated. So now you don't see the pod which ends with R5HC2. That pod is not there. The new pod which ends with 9G, that has been up and running since 14 seconds. Now we'll just describe this because we changed the version, right? Let us see if the version change has happened. Yeah. So now you see the difference. It is 1.7.9 is the image that it took. Earlier it was 1.8. We downgraded it and then made it 1.7.9. Now for when a deployment, right, you can expose it as a service outside. And NGINX is a HTTP service, web service it is. So you can expose it and say that this is my node port, the service which I mentioned, right? One of the type of the services is node port. Services is a advanced topic, or I would say intermediate. So probably maybe after a few months we can deal about those intermediate topics. -o wide is used to get a more described output. Okay, so the pod is running and it's been running since 78 seconds. Yeah, this is the master node, and then I have only one worker, so it shows one node. Yeah, and it picks up the IP address. When see on your laptop when you're running, it will seek another IP address, Kubernetes, similar to your Docker image. It will get some internal address, right? But that internal address to talk to outside, you'll have to do a port mapping, which we will see in this demo. Yeah, so you have this welcome to NGINX. So this port was actually coming from the laptop. And then we did a port mapping of port 30680 to the laptop's 80 port. And then when we access it through browser, we got the service. So similarly, this you can have it like a service for anything. And another question which I have here on the chat was about the zero downtime deployment. Actually, when your pod is terminating, the new one was already in running state. And only when the new pod is in running state, the older one gets to terminated state. So that, and in case the new one doesn't get to running state, the old one is not terminated. It will always make sure that your applications which are running on the pod or the node are well taken care, and there is no problem or loss of data. So that's why there is no downtime. Only when the new thing is completely up and running, the old one is retired. It's not like it's not the other way where it is retired and then the new one comes. Yeah, so this has been our demo, and then we have like 2 minutes. Any more questions which we haven't got to, you can just copy and paste it again on the Zoom chat so that we can take a look. Yeah, another question. I'm not sure this was answered. The kubectl know which K8s to connect. So in Kubernetes, when you have, right, first it will check in the local system. But then if you're connecting to some remote system, we have something called kubeconfig. In kubeconfig file, we set that context of Kubernetes to certain kubeconfig, and then it will switch it. Because from my machine, I can access 100 Kubernetes clusters, right? So this kubeconfig is something like secret information about the cluster. It has a lot of other parameters also. So once you set to that, then you'll be talking to that, because in the kubeconfig, it will say this is the kube API master IP, and then it will automatically get connected to that. So you can switch context, you can unset context, set context, and you'll be able to talk to multiple Kubernetes clusters from the same client. Yeah. Any more questions? We have one more minute.
Nice, you can even unmute yourself and ask your questions.
Yeah, Docker Compose I can tell. So Kubernetes is much more advanced than Docker Compose. So we were using earlier we were using Docker Compose before knowing Kubernetes. It does a similar job, but then after getting used to Kubernetes, we felt it has more more fulcrums and levers for you to play with in order to get your job done easily. Other frequent container images. Sorry. What are other frequent container images? Kubernetes supports a bunch of container images. I think about 5,000 or so are there. So everything which can be installed on the laptop or any server that has been bootstrapped into making it a thin layer. Say even MySQL, if you want to install, maybe it will be like 800 MB file if you download it for the laptop. But then for K8s, it will be hardly few KB files, few KBs of a file to make it bootstrapped. So there are many things. You can check Docker Hub, and then in Docker Hub, there'll be images. There'll be like list of images starting from Alpine to NAScale. And if it is a stateful, if it is a database, usually it comes with 2 disks. That's the only difference between stateless and stateful images. Stateful images will have 2 disks because the second disk is for storing the data. It's the data store persistent volume. No, Docker is not going to be deprecated. Docker will be there, but Kubernetes is ecosystem which is encompassing it. Maybe not all applications would be requiring Kubernetes, so there only Docker can still do for your laptop purpose, right? If you want to build some developer environment or you want to build some microservice, you can still happily live with Docker desktop. Don't need to have Kubernetes. I think that's with the questions for the evening.
Wonderful. Thank you for your questions, and thank you, LG and Rida. It was a wonderful session. And I mean, we will be back. Thank you folks for being here on a Friday evening, and the interaction was very good, and LG and Rida, like always, were excellent. So thank you, LG and Rida, for your time. Thank you, everybody else. And yes, we'll be back. We'll continue the conversation on cloud.
Yeah, thank you all for joining, and thanks Shubhanjali, thanks Pavitra for this opportunity.
Thank you.
And
Lakshmi, we will be
sorry.
No. I was just responding to Jay Lakshmi that if we could get the recording of this, the recording of this would be available on YouTube channel of Women Who Code.
Yeah, and thanks Rida for being an amazing co-speaker.
Thanks, LG. Thanks everyone for joining. Thanks, Pavitra and Shubhanjali.
Thank you so much. Bye. Have a wonderful weekend.
Bye.
Thank
Have
you.
a great weekend.
Bye.